Okay, let's start this recording here. Okay, so last call for practice tests. Make sure you have one. I still have a lot, so weird. If you did do the practice test, I know you all looked at it. It's pretty long, right? So what I want you to do, right, for the test, I don't want you to waste your time on the short answer. Definitely not, right? I want you to focus on the long answers, just like I did for this practice test. I said, if anything, just try the long answers, short answers. I'll say this, filling in these boxes is worth 1.5 out of 2 marks. Okay, so even if you don't go in and actually compute it on your calculator, you can still get 1.5 marks, assuming that all your boxes are right. Okay? And so I would just go through, read through these, fill in those boxes, right? That's not what takes time, really, when you're reading these questions, filling in the boxes. What takes time is putting it into your calculator and second guessing yourself, checking it again, right? And so fill in those boxes, right? But not until you've done those long answers. Okay? It is a long test. What you'll find is we probably will only have time to go through the long answers, but I'll post the solutions to the short answers, of course. Okay. So, all right. Let's see here. This is practice test number 3, solutions. In case this is coming as a surprise, we have a test on Tuesday. Test 3. Okay. So that's going to be important. I did post another Moodle assignment. I know, right? The nerve, which is due, I think, on Thursday or whatever. It is 5 multiple choice questions. So I feel like you can handle it. Just kind of crank it out. Okay. It is stuff that's going to be on this test, so might be good for studying, right? But I just had to sneak another Moodle assignment in there. So I picked only multiple choice ones, which I think is nice. Then you don't have to deal with, do I need a $? Do I not need a $? Garbage. Okay, so, all right. Oh, there's short answer solutions already. Let's steal this. So of course, we'll start with these long answers. They're the money makers. Let me just go back and check. I feel like I told my guys yesterday something that I'm forgetting today. Do practice test number, no, that was, nope. All right, just feels weird. Okay, just didn't want you guys to miss out on anything important. You'll notice that all these long answers are worth the same amount of marks, right? They're worth 10 marks each. So just kind of, there are going to be some easier ones, some harder ones, but they're all worth the same amount, right? And what I will guarantee you is that the types of questions will be the same in the same order. Okay? So what you can do is you can figure out which ones you like the most, go to those first, right? Get your confidence up, and then you'll be ready to brave the last one. Probably is the biggest one. Right? All right, so this one, all right, Jim purchases a mortgage with a $60,000 down payment. He pays end of the month payments of $2,000 for 25 years. If the interest rate is 4% compounded quarterly, what was the original value of his mortgage? Right, so the original value of his mortgage is just how much did he have to borrow, right? And so I'm gonna tweak it to say how much was the house worth, right? Because that's a little bit beyond what we're asking here. So, and depending on how you look at it, the mortgage could include the down payment, could not. Anyways, I'm looking for the total value. So, first thing we're gonna do is go through here and just highlight the three things that we need to keep track of. Right, first one being, when are these payments being made? Are they being made at the end of the payment period or at the beginning? Oh, I did that backwards. Right, so he pays end of the month, right? So monthly is your payment frequency. And what's our compounding frequency? Compounded quarterly. Right? So first thing I would do is I would just sit down and highlight, okay, when are the payments being made? At the beginning or the end? Right here, we've got the end. Our payments per year is monthly, so 12, and our compoundings per year is quarterly, so 4. Okay. Because these aren't the same, 4 is not the same as 12, we have to calculate I2. Right? And so in that case, our compounding frequency will always be F1. That's just a fact. And our payment frequency will always be F2. Okay? So you can just absorb that as fact. Okay? And that's just because we have to adjust our compounding frequency from what it is to be the same as the payment frequency. So then we have to find R1, because to calculate I2, we have to find I1 first. So R1 is the 4%, so 0.04, meaning I1 is R1 over F1, 0.04 over F1, which is 4. Nice clean 0.01. So now we can calculate I2. I2 is 1 plus I1 to the power of F1 over F2, minus 1. Okay. 1 plus 0.01 to the power of F1, which is 4 over 12, minus 1. (1.01) to the power of, and I put my 4 over 12 in brackets, right, just to be safe. I don't know if you have to, but I've never tried not. It's not the same as what I have, so I'll do it again. Okay. I get 0.0033222284. I'll store this in 1. Now that we've got that kind of clunker out of the way, we can make our timeline, figure out what's going on here, right? But regardless, if you're using your calculator or if you're doing it by hand, you'll have to find I2 just to make it fair for marking purposes. You have to show me that you know how to find I2 if you had to. So we've got this timeline here. We'll start today. And I think he's going to make payments for 25 years. And he's making end of the month payments. So I'll put 25 years a little bit above here because our ticks are going to represent our payments, right? So we've got 25 times 12 months, so 300 months. Next one being 299 months, 1 month, 2 months, everything in between. You have to show these 5 ticks, right? Today, the first 2 payments, and then the last 2 payments. Otherwise, it's not complete. He's making payments of $2,000 at the end of the month. So $2,000 here, $2,000 here, $2,000 here, $2,000 here. Great. We will, yeah. These are all paying off some present value, right? And we know that the down payment was $60,000. The 60,000 plus these payments, right? That's going to be the total value of the house, right? So total value of house. So to figure out how much the house was worth, and whether you read that as finding the present value or the total value of the house, it doesn't matter. It'll be clear on the test. This one was a little bit sloppy. Okay. So what else do we know here? That's it. Okay. So we need to find. We do. Thank you. Although I get sloppy, mostly because I've already found the 300 months up there, right? But you're right. I should say that n is time times the frequency, which is 25 times a frequency of 12, which is 300. Good. Okay. In case you're wondering, everything above this is what you need for a complete timeline. Yikes. So you got to work on those timelines. But now you can either calculate it by hand. So first thing we'll do is we'll calculate this by hand, and then I'll show you how to calculate it on your calculator. Whichever way you go is fine, right? They're worth the same amount of marks. So you can either find the present value, because these payments are at the end of each month, right? We just have an ordinary annuity. So the present value is the payment amount times 1 minus 1 plus I to the negative n over I think, right? Yep, nice. Our payment amount is 2,000 times 1 minus 1 plus, and then recall 1.00332284 to the negative n, which is 300, over I, which is 0.00332284. I'm just going to crank it out. Plus 1 to the power of 300 negative equals, and then remember you have to do 1 minus that chunk, right? You can't just do minus 1. It's not the same. Okay. So you want to do 1 minus, I use the previous answer button. So the second equal sign pulls up the most recent answer that it gave you. Okay. So that one's handy. divided by recall 1. I don't get the same, what the, oh, times 2,000. Times 2,000, phew. 379, 431, 0628. 06, yeah. So the total value is the 60,000 plus the present value, which is 60,000 plus 379, 431.06 plus 60,000 439, 431.06.
Instead of writing out all of these numbers, 1, 0, 0, 2, 2, if we identified that as square 1, can we write recall 1?
Yeah.
Fine. Fine. I reluctantly say yes. All right. What's a couple numbers? They're itty bitty too. 0s, 3s. Yeah, that's fine. I'm going on the record saying you're allowed to do that. So, or on your calculator, I'm gonna write my my entries across the page just so it saves a little bit of room. So N, interest per year, the present value, the payment amount, the future value, the payments per year, the compoundings per year, and then the new one, beginning or end, which we have to know now. Okay. So our N was 300, our interest per year was 4, our present value, that's the one we want to solve for. And then we've got payments, so I'm making payments of $2,000. Once I'm done paying this off, the future value is going to have to be 0. And my payments per year, I'm making monthly payments and I'm compounding quarterly, and they're all at the end. So once you go back and solve for this, we find that the present value is 379, 431.06. Then find total value as before. So they're the same. So whether you prefer to use your calculator or calculate it by hand, doesn't matter to me. But you do have to find I2 regardless, which is a little bit kind of silly because you don't actually need I2 if you're using your calculator, but it's just for marking fairness. That's all. Okay. Cool. How can this question change? Well, the obvious change I could make is now the payments are at the beginning of the month. Right? What's an even bigger change I could make? What if you're saving this amount instead of paying off a loan? Right? Then this would become a future value. Right? So imagine for a second that you have savings going in, and then maybe you get an additional payment, right, which would be the same as the down payment. Maybe you get an additional payment, and then I ask you how much do you have total saved? Yeah? Got it? Great. Beautiful.
not get the number that he got in the equation? Because he equals empty.
Ooh, okay. Oops. This here is usually the biggest culprit. So I'll go through and calculate this and make sure that we're getting the same thing there. And then, so 1 plus recall 1 to the power of 300 negative. Oh, error 1, come on.
Yeah, see, that's not it.
1 plus recall 1 to the power of 300 negative equals, I get 0.3697112. 12, yeah?
0.369,
Yeah. And then you have to do 1 minus that. Yeah.
Why are you doing 1 plus? Oh, it's in the back. So you have to plus minus.
Yeah, so I'm dealing with this here first. And then usually the 1 minus is the one that throws you off. So you have to do 1 minus that guy. So the top here should be 0.6302888788. Is that what you get?
So did you do 1 like minus recall and then recall it?
Yeah, assuming that you stored that chunk. Okay.
Oh, we used to buy it.
And then divide by recall 1. Or whatever you've stored your I2 as. And then you should get 189.7
Okay, yeah.
times 2,000.
Got it. Thank you. Great. I think I'm hearing one.
I got that at first too. I'm not sure why.
Thank you.
No problem. Great. All right. Any other questions about that one? Moving on. Payments with an additional value. I don't know if I'm brave enough to kind of name that one. Yeah, let's call it payments with an additional value. Either future value or present value. Okay. Ted purchases a plot of land for $200,000 with a 15% down payment. He then makes end of the year payments for the next 18 years to pay off the property. Assuming that interest is 3% compounded weekly, what are Ted's payments? So here you're gonna have to find the amount of the payments, right? So for as far as a type goes, you'll have to remind me to say the type for all of these though from now on. Find payment amounts. So he's going to make end of the year payments, and interest is compounded weekly. So that's the first thing we're going to jot down. Okay, so we're working at the end. That's good. And our payments per year is just 1. And our compoundings per year is weekly, so 52. Our compoundings per year is F1, and our payments per year is F2. These aren't the same, so we have to find I2. If you want to play it safe, you're always going to find I2, and then it'll just be I1 if you don't have to change anything. So our rate is 0.03, so I1 must be R1 over F1. 0.03 over 52. It's going to be itty bitty. 0.03 divided by 52. Here we go. 0.000 576,923. Finding I2 now. 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.000576923 to the power of F1 52 over 1 minus 1. So plus 1 to the power of 52 minus 1. 0.03044 Nice. And I better store that. Okay. Now let's do our timeline. So our timeline, again, let's just start it today. See where it takes us. So I think he's making payments for 18 years. And he's making end of the year payments. So we can just put 18 years here, right? Because the payments are being made annually. So 1 year, 2 years, and he's making payments at the end of each year, right? So we're trying to figure out what the payment amount is, but at least we know where to put it on our timeline. If these payments were being made at the beginning of each year, right, we would have to shift all these over one. Okay. So you'd have a payment today, and then your last payment would be at the 17-year mark. Because that's how you show that these payments are actually at the beginning of each payment period. You just shift them over one. Okay. So, okay. These payments are paying off some present value. So we know he purchased this land for 200,000. So, and a 15% down payment. So let's find out what the down payment is. Down payment is 200,000 times 0.15, right? 15% of 200,000. $30,000. So we know that $30,000 plus these payments have to total 200,000. So the present value must be 200,000 minus 30,000. So I'll just add that on here. Because we can't have more than one unknown on here, right? We have to know everything except for the one thing that we're solving for. Right? And so we have all the tools to find that present value. We just need to do a little bit of work to do it, to find it. Okay, great. So this here is a complete timeline. Oh, I guess I should put my N on there. No harm, no foul. Got time. And it's time times the frequency. 18 times 1 is 18. Say that again. Yeah, I'm tempted to make them worth more because there's so much work. I think they should maybe be 6 marks. How do you guys feel about that? Because I2's in there.
Yeah.
Now.
Yeah, mark for finding I2, like at least 2 or 3 for the timeline, and then for computing it properly and writing down the work.
6 it is. So then just 4 for your calculations? That's fair. Then you could just crank out some timelines and leave. Or you could memorize the practice test like we talked about. Also a fun option that I would like to see. But I don't want you to risk your grade. I know I'm marking it, but it's different. It's different. If someone actually submits it. Anyways, it would mean memorizing the practice test. Not that fun. Okay. What are we doing here? We have to calculate the payment amounts. So we know the present value, right, of this ordinary annuity because the payments are at the end. And so our present value is our payment amount is 1 minus 1 plus I to the negative n over I. Our present value is 170,000 times the payment which we're trying to find, 1 minus 1 plus, recall 1, 0.030444562 to the negative 18 over 0.030444562 to the 18 negative. 1 minus that guy divided by recall 1. I get 170,000 is the PMT times 13.70183957. Payments must be 12,407.09316. His payments will be 12,407 and 9 pennies. Or if you want to on your calculator, and interest per year, present value, payment amount, future value, payments per year, compoundings per year, beginning or end. N is 18, the interest per year is 3. I'm stealing it here. He borrows 170,000, so it has to be positive, right? Because he gets that amount. He chooses to put it towards this property. We're solving for the payment amount. The future value, once it's all paid off, is 0. And our payments per year is 1, and our compoundings per year is 52, and we're at the end. And you should find the exact same thing. Should be negative on your calculator, right? I'll throw that in there. Because he's making payments. But if you dropped it, right, we don't have negative payment amounts. Right. Cool. So expect to see one very similar to that one. Yeah. Yes. In fact, it's right now. So, yeah, any questions about this one before we move on? Cool. So, yeah, one very similar to this one. The only change that could happen, right, are the payments at the beginning or the end, right? But of course, the amounts will change, but not much else. So here is one that you could do by hand, but it would take you forever. And so this is the only one where I'm saying do not use your formulas. you have to use your calculator for this one. You could try to do it by hand, but I don't see the point. So this is kind of a different situation because we've got a lease. So I think we understand how leases work, right? We borrow some amount, right, to buy a car often, right? Or whatever lease you want, right? But we're talking about cars. Okay. And so you're leasing a car that's worth some amount, right? And so you essentially get this amount as a loan, right? And then you're making payments, but when you're done a lease, you haven't paid it off, right? You would still have to pay a lump sum at the end, right, in order to pay off this whole loan that you borrowed. Right? And so for this one, you have to use your calculator. First, let's talk about when are these payments happening? Are they at the beginning or the end? What's our payment frequency? All that fun stuff. So Felicity leases a new truck worth $50,000. She puts a 25% down payment, then pays $1,500 payments at the end of every month. At the end of the lease period, the vehicle is worth 15% of the original value, right, before the down payment, so the $50,000. What was the lease period in years, right? So how long did she lease this truck for? Assume interest is 4% compounded bi-weekly. So let's just do some highlights here. So she's making payments at the end of every month, and interest is compounded bi-weekly. So we're at the end. Our payments per year is monthly, and our compoundings per year is bi-weekly, which is 26. For some reason, I know the bi-weekly frequency doesn't stick as well as all the other ones. So make sure that you keep track of bi-weekly is 26. This would be F1 and this would be F2. We don't really have to calculate I2 except to show off, I guess. I'm torn because I get you to use your calculator. Let's do it for consistency, but we don't actually use it. So if you don't do it on the test, then that's fine, but I'll do it just for consistency. So R1 is 0.04, I1 is R1 over F1, 0.04 over 26. .00153846 So I2 is 1 plus, oops, what happened here? Yeah, 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.001538462 to the power of 26 over 12 minus 1 plus 1 to the power of 26 over 12 minus 1 .003336325. Go on the record again. If I tell you you have to use your calculator, you don't have to find I2. But if you want to show off, you can. I just find it's easier to do the same thing always. All right, so what does this look like in terms of a timeline then? So we've got some unknown time, right? We're trying to find how long is this lease for, right? But we know the value at the beginning and we know the value at the end, right? And so she gets the car today, and then for, when is she making these payments? She's making these payments at the end of every month. So she's making payments for n months or t years. As long as you have the n months on there, that's fine. I had someone yesterday say, oh, can we put t on there because it's confusing? Sure, but it's still unknown. So we've got our first 1 month, 2 months, to n minus 1 months. And what are our payment amounts? $1,500 at the end of every month. All right, 1,500, 1,500, 1,500, 1,500. So what's going on here is that this amount is going to be paying off some present value. But at the end, there's also going to be a future value owing. Right? So some future value, oops. So that future value is the amount that she would have to pay off the rest of the loan. Right? And so we know the total of the truck she bought was $50,000, right? Yeah. So the total worth is $50,000. So the down payment is 50,000 times, and she made a what percentage? 25% down. Oh, that was inconsistent of me, wasn't it? Getting sloppy. So the down payment is 12,500. So that she doesn't have to make payments on, right? So that 12,500 out of the 50,000, that's paid already, right? Starting today. And so we're only making payments on the remainder. And so the present value must be the 50,000 minus the 12,500. $37,500. Right? So the present value is 37,500. So that's what these payments are chipping away at. Right? Then we know that the future value here, at the end of the lease period, the vehicle is worth 15% of the original value before the down payment, right? And so the end value is 50,000 times 0.15. Wah, wah. So it's still worth 7,500, for better or for worse. So this future value, maybe I'll write it a little smaller, is 7,500. Just make a note here. Would need to pay an additional 7,500 to pay off the loan of 37,500. All right. So that's the tricky part. And that's why we don't want to do this by hand, right? We want to use our calculator. Because what happens on our calculator, right, is that we have N and the interest per year, present value, our payment amount, our future value, our payments per year, our compoundings per year, the beginning or the end. We're trying to find N. Our interest per year is 4. We get a loan of 37,500. We're making payments, so negative 1,500. And then we would have to pay 7,500 in the end. Right. This one is probably the trickiest thing, right? But remember also that, okay, well, if we got a loan amount, that has to be positive, but also our future value and our present value have to have opposite signs, right? And so if we know the present value has to be positive, then yeah, the future value has to be negative. And we're making 12 payments per year, and our compounding was 26, and we're at the end. So filling our slots, we've got 4 interest per year, 37,500 present value, 1,500 negative payment, 7,500 negative future value. Payments per year is 12, compoundings per year is 26. Just double check you're at the end. Right. It'll say begin at the top, in the top strip if you're in the beginning mode. And now we can compute N, and we find that N is 21.09740471. So N must be 22. Right? We always have to round up. Yeah. So if you go second and then the payment button, there's the beginning second menu up top. And then, so if you're in there, then you go second enter to switch between the two. Got it? Nice.
And then you just go to
Yeah. Or compute N. Cool. So make sure that you're getting that same N. So N has to be 22 because we can't make 21 payments because it wouldn't quite be enough, right? We have to go to 22 payments. So now N is time times the frequency, 22 times time in years times the payment frequency, just because N is the number of payments, right? So we have to use the payment frequency as our F. And 12. So T is 22 divided by 12. 1.83 repeating. What was the question? What was the lease period in years to 2 decimal places? The lease period was 1.83 years. Cool. Well, I guess I should sneak it in. What type of question was this? I'd call this a lease question, but you have to do it on your calculator. And you can expect something very similar on the test. It might be a car, not a truck. Don't let that throw you off. You're gonna stay calm. Don't second guess yourself. The number of times that I've had to ignore erased stuff and just kind of read the erased stuff is crazy. Just go with your gut. You're probably right. Stick with it. Like ignoring this, it'll be all scratched out. Like ignoring this, this is good. You did it. All right. Any questions about that one? Ooh. Oops. Aha, my favorite thing, perpetuities. All right. Well, you know what? I'm going to split this up. I'll just copy part A and then do B because I need more room. Today is January 1st. Wouldn't you know? You decide to create a perpetuity which will pay for your TV bills forever. Your bill is approximately $80 at the end of every month. So the whole idea here is we need to have some initial investment. Remember, perpetuities are those fun ones where we just invest some amount and then we can just skim off the top. At every compounding, we swoop in and we take out the interest, but the principal stays the same. And so we can always go in and pull off interest off the top forever, hence perpetuity. Okay. Probably the funnest thing we do all year, in my opinion. So you're gonna make a perpetuity where you can skim off $80 at the end of every month forever. Okay. So let's just see here. Let's highlight some. So we're doing at the end of every month. Part A says if interest is 5% compounded quarterly, how much must your initial investment be? So what's the present value of this perpetuity? These questions, this perpetuity question, which is the type of this, I guess, they're going to start normal, and then part B is going to have this kind of weird, absurd situation, as we'll see in part B, right? But you just treat them as two different questions, and then you can just add them up. Okay. You'll see what I mean, but we'll start with this normal one. So the payments are at the end of every month. I'll say the type here is a perpetuity. And we're making payments per year of monthly, so 12. And compoundings per year is quarterly. So 4. This is F1 and this is F2. They are not the same, so we have to find I2. So we'll start there. R1 is 0.05. Oops, yeah. And then I1 is R1 over F1. 0.05 over 4. 0.0125. Oh. I2. 1 plus I1 to the power of F1. Oops. Over F2 minus 1. One plus 0.0125 to the power of 4 over 12 minus 1. 0.0041494425. I'm going to store that in 1. As far as our timeline goes, it goes on forever, right? So we start today which we're told is January 1st. It doesn't actually matter. And then at the end of every month, 1 month, 2 months, 3 months, etc. We need payments of $80, $80, $80. So your timeline for a perpetuity is going to look something like this, right? Because it never ends, you can just do 3 or 4, and it just drops off. Okay. These payments are all coming from some present value of a perpetuity. Present value of a perpetuity due if the payments are at the beginning. Right? So now, this would be your complete timeline. I think I forgot to do that for the, but I think you're getting the idea. Present value of a perpetuity is the payment amount over I. Right? We have to use I2, right? But besides that, it's just 80 divided by 0.004149,425. So we would need $19,279.77916. We would need $19,279.78 as our initial investment. Cool. Any questions about that one before we go on to B? Yeah. That's right. Yeah.
And like in any annuity or perpetuity situation like that?
Yeah. So if you calculated an I2, that's your I. Yeah. 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 Good. But yeah. All right.
My answers are all wrong, but I followed everything else right.
That's pretty good. I think that's really good.
I was like, yeah, that makes a way more sense.
So part B is where I give you this kind of weird situation where we have to top up our perpetuity, right? And so every 3 months, your roommate loses their job and decides to watch pay-per-view movies all month. Okay, obvious solution: get a new roommate. During this month, your TV cost triples because of your roommate, of course. If your roommate begins his job loss cycle in 3 months and then every 3 months after, how much must your initial investment be now, right? And so we have to have, on top of these normal payments, right? Here he's going to lose his job, and so our TV costs are going to triple, right? But one of those 3 is already taken care of in this 19,000 that we just found, right? So we only have to find the value of paying another 80 plus 80 every 3 months, right? So 160 additional here, 160 additional another 3 months later, 160 additional another 3 months later, right? And then we can find the value of that perpetuity and just add it to the 19,000. And that perpetuity would be able to handle that kind of weird, irregular, or regular pattern, I should say. So let's see here. So if your roommate begins his job loss cycle in 3 months, right, that's telling you that it's at the end of the period, right? Because it's not starting today, it's starting in 3 months and then in 3 months after that. So it might be easier to just jot this down as a timeline so we can have a look. So today and then in 3 months, and then in 6 months, etc. We need payments of $160 on top of the $80 that we've already got put away. I'll just make a little note here. Need 160 on top of the 80 from part A. Okay. Triple the costs, yeah.
So if the DD work is getting tripled, then why 160?
Because so you'd have a cost of 3 times 80, right? But you've already accounted for the first 80 here, right? So you only need an additional 2 times 80 in the other situation. Yeah, cool. So now, so every 3 months, that's kind of weird, right? But every 3 months is actually, we can squeeze 3 months into a year 4 times, right? So quarterly is actually a length of 3 times, or 3 months, sorry. And so now we're still at the end, but our payments per year is 4. Every 3 months is quarterly. So this would be our F2. And our compoundings per year is going to stay the same from earlier, right? We don't have a new interest rate. So it's going to be quarterly as well. Celebrate. Why is it Party Central? Finally, they're the same. We don't have to do anything. Phew. Let's do it just to show you that you don't have to do it. To reassure you. I1 is R1 over F1. 0.05 over 4, which is still 0.0125. If you had to find I2, 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.0125 to the power of 4 over 4 minus 1. 4 over 4 is just 1, so then you have 1 minus 1 plus 0.0125. So for this reason, I would just, if you're not sure, right, you don't want to lose any marks, I would just always go ahead and find I2, right? Sometimes it'll be redundant, right, because it's the same as I1, because you didn't actually make a change. But to play it safe, right, instead of trying to figure out if you need to find I2, you can just always find I2. And sometimes you won't have to need it. Need it in the end. So this is our new I, and so our present value of the perpetuity is the payment that we need over I, which is going to be 160 over 0.0125. 160 divided by 0.0125. Even 12,800. Right? So we would need a total of what was this other one? 19 something? 19,279.78. $19,279.78. I get 32,079.78. Nice. Cool. So, yeah. All right. Any questions about that one? Yeah. No, because it's forever. Yeah. Yeah, so perpetuities are just simpler all around. The formulas are easy. The timelines are easier. It's a fun concept. So, are we ready for question 6 or what? It is a behemoth. I'm not scared. Oh. Okay. This one's a biggie, right? But it's also worth the same amount of marks. I'd say it's significantly harder than any of the others. And I was talking to Steve, who's also teaching a section, and he said because I was like, oh, how long is yours? Because I find this test is really long, but I just work off of what everyone else is doing. And he said, oh, I only do 4 long answers. I was like, oh, okay. But he was like, but they're all 2-part. So they're all like this. So I don't know what you guys would prefer.
No, I prefer a whole.
But I was like, I think I'll just stick to the way I have it.
Yeah. Appreciate.
I was like, oh, yikes. I guess it depends on, how you've approached your course, but I'm like, no, one of these is plenty.
Or you could just give me 3 extra 1 part. I'll take that.
Okay.
Just saying.
This one will be fun though. Let's call this type Sesame Street. No. Type. Yeah. Two parts, maybe. Reason being, so Oscar had 44 years on Sesame Street where he put away money at the beginning of every month. So for 44 years, he's putting away money, right? And then at the end, whatever he's saved up is going to go towards paying out some amount, okay? And so his RRSP earned 75% compounded monthly. Because of this, Oscar saved a good sum for retirement and will now receive payments from an annuity earning 5% interest quarterly, different interest rates, right? Got to keep track of that as well. At the end of every bi-weekly period of $200 for the next 15 years, right? So he's saving until he has some amount after 44 years. And then we know that he's going to get payments of $200 for 15 years out of that amount. Right? And so it's going to be kind of this domino effect where we know these payments, so we can figure out what the value is at 44 years. And then we know the value of what he's saved up, right? And then we can figure out the payment amounts from there, right? So that's why it's 2 parts. Right, kind of boom, 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 ding, ding. Playing around with different sound effects. Anyways, so, all right. for this one, because we've got basically two different timelines joined together, I'm going to start with the timelines and then I'm going to list the information underneath them, just because it's easier to look at them and then say, okay, well, this one's at the beginning, this one's at the end. This one has a payment frequency of this one has a payment frequency of that. Okay. So for this one, I will start with just doing my timeline so I can sort all this stuff out. I'm gonna need lots of room here. So today, and then he's making payments for 44 years. I'll just put it in the middle. Oh, I should put it up a bit. And then he's gonna get payments. So this length is 15 years. So however you want to indicate it. If you want to write 15 years here, that's fine by me, right? But technically, it's today and then 44 years plus 15 years later, right? So technically, we're at 59 years there. But like I said, if you want to do just 15, that's fine by me. Because the length of that section is 15 years. All right, let's start here. I'm going to start by drawing out the first section, and then I'll draw out the second section. So Oscar had 44 years on Sesame Street where he put away money at the beginning of every month. And his RRSP earned 7% compounded monthly. Okay. So down below here, I'll leave myself quite a bit of room, but beginning and our payments per year for this first section are monthly, and we're compounding monthly. Can you believe our luck? Woohoo. F1 and F2. Here, our rate for this portion is 7% compounded monthly. So 0.07, so I1 is going to be the same as I2, which is R1 over F1, 0.07 over 12. Oh, I'm going to write it underneath here so I don't pull into the other section spot. 0.00583 repeating. I'll store that in 1. If you wanted to, you could go ahead and calculate I2, but this question's big enough. All right, so we've got payments coming out monthly for 44 years. So 44 times 12 means we have 528 months. Oops. $527 months, 1 month, 2 months. I had to cut it down to M's. It's fine. And he's making some unknown payment amount at the beginning of every month, right? So that would start today, payment, 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 and end at the 527 mark. These payments are all going to be worth, at 44 years, some future value due And n here is going to be n is time times the frequency, which is 44 times 12, which is 528. Okay. So that's that first part. Let's dive into the second part. Second part. Because of this, Oscar saved a good sum for retirement and will now receive payments from an annuity earning 5% interest quarterly at the end of every bi-weekly period of $200 for the next 15 years. So now we can jot down this information here. So now we're at the end. Our payments per year is at the end of every bi-weekly period, 26. Compoundings per year is quarterly. This is F1, this is F2. R1 for this is 5%. 0.05, so I1 is R1 over F1. 0.05 over 4. 0.0125. Here we have to calculate I2. May as well do that. 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.0125 to the power of 4 over 26 minus 1. Sneak that in there. 1.0125 to the power of 4 over 26 minus 1. I get 0.00191298. I'll store this in 2. Nice. So let's map this out now. So 59 years, but the length of this section is only 15 years, right? So we've got 15 payments for every bi-weekly, or 15 years of bi-weekly payments. So I get 390 bi-weeklies. Right. 389 bi-weeklies, 1 bi-weeklies, 2 bi-weeklies. Now we know the payment amount and they're at the end of each payment period. So we start at the 1 bi-weekly. So 200, 200, 200, 200. These are all mapping back to some present value, which is going to be the same as the future value due. Right. And n here, I'm just going to go time times the frequency, 15 times 26. So here, what's probably tough about this one, right? I tell you that you have to use all the formulas. You can't use your calculator. You're allowed to use your calculator to check your answers, right? That's allowed. You can definitely, once you're done, go back and check it with your calculator, right, with the built-in functions, but you have to show your work with the actual formulas. All right. Beautiful timeline. Okay. All right. So the first thing we're going to do, right, is we're going to figure out, okay, well, what amount do we need to sustain these $200 every bi-weekly for 15 years? That's going to be the same amount that he has saved. So then we'll be able to find the payment amount. And so I'm gonna put a little subscript 1 here, right? And then maybe a subscript 2 on there, right? Just to indicate which order I'm doing these calculations in. So present value 1 is the same as future value due 2. But from there, I'll be able to find the payment amounts. Okay. I guess this is your complete timeline, which maybe should be worth even more than 6 marks. Complete timeline. So the first thing we're going to do is we're going to find this present value, which is just an ordinary present value. Got to keep track of all that stuff too. Right? So we've got our payment amount times 1 minus 1 plus I to the negative n over I. Our payments are $200 times 1 minus 1 plus I. Remember, I for this part has to be I2 from the second part, right? So store 2.
Oh, okay.
Okay. So you got to keep track of which I goes with which section as well. So we've got 0.00191298 to the negative n. We said n was 390. Nice. Over 0.00191298. All right. So recall 2. Oh, phew, I did store it. I was worried for a second there. Plus 1 to the power of 390 negative equals 1 minus that guy divided by recall 2 times 200. He needs to have saved $54,933.26678. He needs to have saved $54,933.27, which is now going to be the same as the future value due. So now your future value due formula, right, is your payment amount times 1 plus I to the n minus 1 over I. We've barely calculated any future values today, have we? Fun twist. That is not on purpose, actually.
And the whole thing times 1 plus I.
Mm-hmm. What's important here is you use your recall 1, right? So you have to keep track of your I's. And it's 80% attitude. Any test is 80% attitude. 54,933.27 is going to be the payments, which we're trying to figure out what they are, times 1 plus, recall 1 is what? Just double check I saved it right. Phew. 0.00583 repeating to the power of n. Thank you. Now it's -1, just to throw you guys for a loop. 0.00583 repeating times 1 plus 0.00583 repeating. Okay, plus 1 to the power of 528 minus 1 divided by recall 1. I'll pause and jot this down in case I muck it up. 3,525. Oh no, I'm positive. I'm positive I'll mess this up at some point. 3968 times 1.00583. Oops. Some of mine keep not writing. I'll store that. And then I'll do 1 plus recall 1 times recall 3. Payment has to be 54933.27 divided by that guy. Womp, womp, womp. 15.49197183. His payments are $15.49. Right. So $15.49 at the beginning of every month for 44 years. We'll be able to sustain payments to him of $200 every biweekly for 15 years. Food for thought. Any questions about that one? You can expect to see one like that, definitely, but you've got the tools. I'll post the solutions for the short answers. 80% attitude.
You know what?
See you guys on Tuesday.
Like, you broke that down into one question each, and it would be a problem. Crazy. Like, I feel like I'm gonna have to read it once, do the one part, and complete it, and then read it again and read the second part. Or I'm never gonna
Yeah, you'll definitely want to like
attack that one.